Hi guys, welcome back to my channel. So this video would be a basic understanding of streams and the difference between collection and stream. So we have very good examples over here, so don't skip the video, watch it till the end. Let's get started. Let us start with the introduction of streams. So what are basically streams? So streams we can consider as a sequence of elements from sources that support data processing operations. Let's break this definition into bits and pieces. So what do we mean by sequence of elements? So just like collections, streams are also a sequenced set of values of a specific element type. So a stream will have a set of values only of a specific element type, okay, just like in collections. And source. So when we say source, the source of a stream could be any data providing source such as collections, arrays, or input output resources like files or any other input output resources. Okay, so this will be the source for any stream, and data processing operations would be like database like operations and operations like filtering, map, or reducing that stream, or doing some match, etc. Okay, so basically a stream is a sequence of elements from different sources, and these elements support the data processing operations. Okay, so streams are basically, they manipulate collections in a declarative way. So when we say declarative way, so consider if you know the database queries, right? How do we generally write them? We just say select from so and so by giving the various conditions, right? So it's like more of declaring what you want from the query and not how you want it. Okay, so directly if we work with collections, we ourselves like have to write the for loops or if loops. But when it comes to streams, we directly mention what we want to do with that collection, and we are not telling the stream how to do it. So that is the basic definition of a stream. So to understand streams in more detail, so let us look at some of the differences between what are collections and what are streams. Okay, so collections, as we all know, all the elements are computed before they can be added to the collection. So whatever operation we have to do, so the final list of elements, the final data structure, we add into the collections. Okay, so it is more of like the time and space complexities like array list, linked list. So these are like all the elements are computed before adding to the collection, right? But when it comes to streams, so streams will compute data as and when required. Okay, so it is like whenever we need the result, then only the data is computed. Otherwise, it is not computed. So as and when required, the operations are performed on that source, on that data source of the stream. So collections are like eagerly constructed. The final computation of that list is done, and then they are added to that collection. So it's like eagerly constructed. But when it comes to streams, they are lazily constructed collections, we can say, because we are doing the operations only when we need them. Okay, and collections is more of a supplier driven. So consider an example. Okay, consider a warehouse or some shop. So it is like, first I will fill up my shop with all the items that I want to sell, and then I will open my shop and sell it. Okay, first I'm filling up my shop and then I'm selling it. So that is more like a supplier driven. But when it comes to streams, it is more like a producer and consumer kind of behavior. So when the consumer needs it, then only the producer will produce it and give it. Okay, so this is more like a producer and consumer kind of. Suppose if you want to create some stream where you want to know the next prime number, okay, next prime number. So what happens? So if you use collections, will you be able to do it? No, right? It is kind of an infinite loop. But with streams, Whenever the consumer needs it, we can give, it will compute the prime number and it will give the next prime number. So it is like the infinite loops can be handled with streams. So we will look into this prime infinite loop example more in the next videos. Okay. And next, collections are more of external iteration. Okay, so if we take any collection, so if we see the example here, we are explicitly iterating the list. Okay, so suppose we have an example wherein we have to iterate or do some operation. So generally, how do? We create a for each loop, right? So we are only iterating through the elements of the collection. Okay, or otherwise we take an iterator, we create an iterator of that, and then explicitly we will take a while loop and then do the iteration. So this is nothing but external iteration for collections. But when it comes to streams, what happens? Okay, so when you want to get, suppose you have a list of dishes. Okay, as we see, there is a dish object here, and dish could have some name or some other features. So what we are doing is, we are just mapping it. We will see these methods more in detail, and then we are just collecting. So we are not doing any external iteration here. Okay, it directly starts executing the pipeline of operations. There is no iteration. So the iteration is internally handled by the streams, and because it is internally handled, it is handled in such a way that it is more efficient, and also it can be parallel as well. Okay, based on the operating system, these internal iterations can be more efficient when compared to explicitly iterating the collection. Okay, because as we chain many of the operations, those can be handled parallelly. We will see this in more details later on. Okay, now coming to an example, right? Suppose if you have a collection of dishes. Okay, and you have a use case where you have to sort these dishes, like you want low calorie dishes. Okay, so you have a dishes list. Okay, so what you want is less than 400 calories, and sort them in ascending order of these calories. Okay, and then you just need the name of the dish. Okay, so if this is the use case, how do we do it generally? We will iterate through that list, like through that menu object. We will get each of the calories, and then we are first filtering out the low calorie dishes, okay, which fall below 400. So that is the first step we will plan to do, and then we will use some comparator to sort this, okay, to satisfy the second condition, and then we will again loop and then get the name of these dishes. Okay, so yeah, so here this low caloric dishes which we have created, this is not actually giving us any, it's not actually useful, right? We are just using it for our intermediate operation. Right, so this is like we have two for loops, some anonymous class, if loops. So a lot of processing is going on here if we are not using stream. So now consider for the same use case, if we use streams, then how simple it becomes. So we are just creating a stream, we are filtering based on the dishes which have less calories, we are sorting them based on the calories, and then we are just getting the name of the dish and collecting in the form of a list. Okay, so it is that simple. So we are not iterating here explicitly. The iteration is happening internally, and moreover, internally these operations could be done parallelly. Okay, so this is how simple the operations become. It's more of a declarative way, right? Filter, sort, and then map, and then collect them. But here, if you see, it is a bit like the external iteration where you have to write the for loops, where you have to write if conditions, and if you want to write other operations, like if you have tomorrow, if you have some other use case, then you have to repeat all of this again, right, for that use case. But if it comes here, that would be again very simple, because you are just adding a new lambda expression to that another list. You will have a different lambda expression. That's it. Now let us look at a very good example which gives a very good differentiation of collections and streams. So a collection in Java 8 is like movie stored on a DVD. Okay, you have the entire movie stored, then you put it in the player, and then you will watch that movie. So it's like you have the entire movie already constructed, already computed, and then stored on the DVD. So this DVD is like a collection, and that means so it is like eager construction, right? Before even playing, it needs to have the entire DVD. It's not like you can enter half of the DVD and then start playing and then the remaining half. So it's not like that, right? So a collection that holds all the values that the data structure currently has. So every element is computed before it can be added to the collection. So this is like, oh, you have everything and then you start using it. Now when it comes to streams, so suppose if you are watching movie over internet, okay, on any OTT platform. Okay, so what happens there? Okay, you get some data in the form of frames or streams, right? And then you watch it, and then the next data comes. So it's not like you have everything stored in your system, right? Only a part of it you just watch, and then the next part comes. So it's like lazy constructed. So once you're watching, while you're watching this, the next frames are constructed. While you're watching this, the next frames are taken and constructed. So it's like streaming videos, or suppose if you even see the matches which come, the entire match, is it completed? No, but still we have the live streaming of that match. So as and when the match proceeds, we get the stream and then we can watch it on the TV. So that is a very good example for the difference between collections and streams. Streams, as we said, um, what you want and not how you want it. Okay. And another good example would be browser internet search. Okay. So suppose if you are searching something on any search engine, what happens? You get some, suppose you search something, you get some 10 results, right? And then if you go to the next page, then it will process and show the next 10 results. So it's not, if it starts searching the entire internet and then starts displaying, you will have to wait almost forever for that result, right? So what those search engines do, they just compute the first set of results. Then if the user needs, then if the user goes to the next page, the next set of results is computed. So streams are also like they work in this fashion. Okay, when you need the next one, then it will compute and give it. Okay. Let us move on to the characteristics of streams. Okay, so there are three basic characteristics of stream. The first one being pipelining. Okay, so in this pipelining, so we can use, like internally it has many methods which we can use, and these in turn take some lambda as input and they again produce a stream. Their output will be a stream. Okay, again sorted, if you say it takes some lambda again, and again its output will be some stream. Okay, and map, again it will take some lambda, compute, and then its output is a stream. So basically we can pipeline this various operations in streams. Okay, filter, sorted, map, and there are many more, right? And then we have some terminal condition, like in what way you want to end the stream. So till you do not have this terminal operation, the stream, these are not computed at all. Okay, so this is the terminal operation. So in this way, we the various operations are pipelined in the stream. Okay, and internal iteration, as we already saw. So if you look at the diagram here, let me scroll it. Yeah. So in streams, we have internal iteration. So our code is directly going to call the stream, and the iteration is handled inside the stream. But when it comes to collections, the elements are stored, but it is we who is supposed to write this iteration code. Explicitly, we are iterating. Okay, so this is one characteristic of stream, that is internal iteration. And the third one is streams are traversable only once. If you want to do the operations again, so you'll have to create another stream and then work with that. Okay, but once the stream is traversed, it cannot be consumed only once. So let us understand that with an example. So here our data source is a collection. So we created the stream, and then for each we are just printing the operation. So if we try to traverse again, we will get an illegal state exception saying that the stream has already been operated upon or closed. If you want to do something again, you will have to create the stream again. So streams we can traverse only once. So for internal iteration, I will give, I wanted to mention a very good example. So consider you have your kid, okay? Suppose the name of kid is Sophia, okay? And Sophia has put all the toys on the floor, okay? And you want her to pick up her toys and then put them in the proper place. So then what you say? First, if suppose if we are doing an external iteration, then what happens is you will say, okay, Sophia, put the toys away. And is there a toy on the ground? Then Sophia will pick up one thing, and then she will say, yes, there is another ball which I have to pick up. Then again you will say, okay, you put the ball in the box, and is there something else on the ground? Then your kid will say, yes, there is also my doll on the ground. Okay, so then you will say, okay, put the doll in the box. Is there something else on the ground? And then she will say, yes, there is a book. And then you'll say, okay, put the book also in the box. And is there something else? And then she will say, no, nothing else is left. And then you'll say, okay, we are done. So this is something like an external iteration. Okay. Now, same thing if we think of an internal iteration, sorry, how it would happen. What you will say, Sophia, put all the toys that are on the floor inside the box. Okay. If I repeat, put all the toys that are on the floor inside the box. So what she can do? First, she can pick up something with one hand. Okay. Some other toy with another hand. And then she'll put in the box. Maybe something that is closer to the box she will put first. Okay. So in that way, she can parallelly do collect the toys and then put them in the box. Right? Will it not save the time? So this is something like internal iteration. Okay, which toys to pick up first, how to pick them up, can she pick up more than one toy at a time? So all this is decided by Sophia itself. So this is like internal iteration, right? Similarly, in streams also, so when we give a lot of these mappings, right? So when we have these pipelining operations, so the streams internally, it does some short circuiting or some other operations, which we will see in the later videos, and it will make it will combine these operations in such a way that efficiently the result is computed. Okay, it's not like it will first filter the entire stream and then it will give that resultant stream to the to sort it, and then it will sort the entire stream. So it's not like that. So these things, so suppose if you want to collect only limit this to only 3 elements. Okay, so first filter will compute one element, will sort, second, and then the third. So once that is done, all of the operations, all of these pipeline operations are stopped. So everything is not computed. So in this way, these internal pipeline operations are combined, and then an efficient processing is done, an efficient iteration is done, internally in the streams. So now let us see these stream operations in a little more depth. Okay, so we can divide them into basically intermediate operations and terminal operations. Okay, intermediate operations are operations that can be connected together, as we saw. Like here also I have the same. These are connected together. So these are intermediate operations. And they don't perform any operation until a terminal operation is invoked. Okay, so these don't start performing until the terminal operation is invoked. Okay, as we saw in the previous example, if we know what to do at the end, then only we'll start processing. Okay, till then the processing won't happen. And they are lazy, yeah, because they depend on the terminal operation. Examples would be filter, map, limit, sort, distinct, right? Yeah, and as I mentioned earlier, their output would be a stream. Okay, terminal operations, so operations that close a stream and produce some result are called as the terminal operation. So basically we collect. Okay, so we can collect in the form of a list, or we can it can return some integer if we are getting the count, or it could be void as well. Okay, the result can be any non-stream value. Okay, and examples would be for each, or count, or collect. So these are terminal operations. They close a stream and then produce a result. Okay, and intermediate operations, they perform operations lazily and then they produce another stream, which can be then pipeline or either a terminal operation applied on it. Okay, so yeah, filter, map, limit are here the intermediate operations, and then converts. This collect is the terminal operation, that is converting this stream into some resultant list. Okay, so these are the stream operations. So I hope you have now the basic understanding of what streams are. In the coming two to three videos, we will go more in depth about streams and how we can write some complex queries by grouping and the terminal operations as well. So that will be very much helpful for you. Okay, so stay tuned to my channel. Thanks for watching.